Good morning, everyone. We'll start our class. Why the strength is so less? Uh, you can send your attendance first. Quickly, please send your attendance. Then we'll start the class. Okay. Okay. In the previous class, we have started discussing this interprocess communication, and we have discussed in this what is a pipe, what is named pipe, what is the use of the pipe, what is this interprocess communication, what is the need. Then we have discussed what are the main advantages of P open and P close function. What will be the advantage with the P open and P close instead of directly using the pipe function? All the task what we used to do, creating a pipe, closing the unwanted file descriptors, the ends, everything that can be easily handled using a P open function, and finally closing it using the P close. It was very easy. Now we are going to discuss about the new terminology, this word called filter, next the co-process, and then we are going to discuss about the named pipes that is called as a FIFOs. Three things we are going to discuss. One is the filter, next will be the co-process, and the third one will be the FIFOs. Three things we are going to discuss. See, any program, any Unix program what you write, which is in the C language, that you can call it as a filter. When you can call that program as a filter is that program should read this input from the standard input, which will be the default standard input, that will be the keyboard. It will be the default standard output, that will be the display. Therefore, that program which reads from the standard input and writes the output to the standard output, then that program you can call it as a filter. That you can call it as a filter. Then that filter is one example that we are going to discuss now. See here there is one program. This program, what it is going to do is it is just going to convert from uppercase to lowercase. See, character int C get char means it gets a character from the standard input. If that it is not equal to end of the file, then it will come inside. Until I enter the end of the file, for each character by character, it will give the positive value. It is not end of file. It will come inside. Then it will going to check whether it is upper or whether it is in the uppercase. Then if it is in the uppercase, change it to the lowercase. These are the inbuilt function. To lower of character C. To lower of character C. See here, it is going to return. If you enter capital A, it will give a small a. Then that will be stored in the variable called C. Now, if that put character, if it is a end of the file, put character is get character means get from the keyboard. Put character means print it on the screen. Each character print it on the screen. Standard output. That each character which is changed to the lowercase, that will print it on the output screen. That will be on the display. If that is an end of file, then it will show you the error, or else if it is the last line, if it is a slash n, if you have entered slash n, if all the character is completed, I think you have entered your name, everything in the uppercase, and after at the end you have entered enter keyword, then that is called as a slash n. If you enter that slash n, if that matches this if condition, if C equals slash n, F flush standard output. F flush is nothing but whatever is stored in the standard output, it's a buffer. Standard output, it's a file. What a file means? It's a buffer. It can store something. From there, it will be thrown completely to the screen. See, actually, how the standard output works is you should understand this. The standard output, it is a line buffered. Standard output, it is a line buffered. Line buffered is nothing but until it sees the slash n, it is not going to throw the output to the screen. When it sees the new line character, it throws the entire whatever it is stored in the uh, that file memory, the buffer, everything will be thrown to the output screen. ಸ್ಲಾಶ್ ಎನ್ ಯಾವಾಗ ಬರುತ್ತಲ್ಲ ಆ ಸ್ಲಾಶ್ ಎನ್ ಸಿಕ್ಕಾಗ ಅಲ್ಲಿ ಏನ್ ಸ್ಟೋರ್ ಆಗಿರುತ್ತಲ್ಲ ಅದ್ರ ಪ್ರೀವಿಯಸ್ ಅದನ್ನೆಲ್ಲದನ್ನು ಔಟ್ಪುಟ್ ಸ್ಕ್ರೀನಿಗೆ ಡಿಸ್ಪ್ಲೇ ಮಾಡುತ್ತೆ. It is directly thrown to the output screen. If it don't finds the slash n, then it will not going to throw it to the output screen. That is why standard output is called as line buffered. There is another type called full buffered. Full buffered means until that buffer size what we have given, until it gets filled, nothing will be shown on the screen. That is full buffered. F flush standard output, if you write whatever it is there in that file, standard output file, completely it will thrown to the default terminal that is been attached to the standard output. Which will be the default terminal attached to the standard output? That will be the display. Which will be the default terminal attached to the standard input is? That will be the keyboard. This is one simple filter which converts, as the name suggests, it reads from the standard input, it's going to write to the standard output. Then you can call it as a filter. Just remember this much. F flush, this program, it is just going to convert from uppercase to lowercase. This program we have compiled, converted, and we are going to store it in the executable file called my uppercase to lowercase. This is the executable .exe file name. You have stored this in one place, some place. Next, we'll write another program. What is that another program is? This program which is going to drive this program. Drive means control. What we are doing here is, see, I think it is. This is visible now. We have taken one character array and file, there is a pointer. We are going to read, see, the pipe symbol. Now we are linking the pipes with this program with a filter. Try to understand this pipe concept that we are linking with the this filter now. What we are doing is p open, see this executable file, and opening it in the read mode. You have opened the pipe and you have opened in the read mode R. If it is null, then it is a problem. You will throw the error, you cannot open the file, or else it will execute this file. It will execute this file and it will write the output. Means that's output you can read. That file descriptor is been returned. File pointer into the standard input. Infinite times, for loop, infinite times, what we are doing is fputs. Fputs means we are going to write it to the file. We are going to write to the file. FgetS means we are going to get the data from the file. Fputs means write into the file. Which file? What is the address? The address is standard output. Even the standard output is also a file. Standard input is also a file. We are going to write this string prompt, this string redirection operator into the standard output. We have written this we have stored this in the standard output file, this content prompt. After that, we have flushed everything, flushed the standard output. After that, fgetS. F get S is whatever it is going to point. Now see, my UCLC means this program. What this program will do, it will get the characters and it will convert from uppercase to the lowercase. Means it is going to write it to the standard output. Here what we are doing is, this program is going to call the previous program. This program is going to call the previous program. How? This p open, it is going to execute that executable file, and data it is there in the standard input, and this address is there, the file pointer. From there we are going to read. What is this line and max line is? Line is a character array, means whatever you read the uppercase characters, that will come and stored in this character array called line. This max line means what is the maximum size of the buffer, 500 bytes, 300 bytes. If this is null, then you are going to break. Or else, if you get something, that will be stored here. Once again, you have put as line comma standard output. See, what it is just doing is, from the standard input output, what you used to do here, from the standard input you are going to read and you are going to write it to the standard output. What we have done is, we have bought the standard input into the, through the pipe we have read, and then through the standard output we have printed. You can visualize like this. See, this will be the diagram. Transferring the input using the p open. Transferring the input using p open. Using the user terminal, he has entered the lowercase character. We have passed the input lowercase. This filter program has converted into uppercase. That program that we have passed to the this will be read by the parent process, that is called a p open. Using the p open, we have sent the data to the standard output. And once again, prompt user will enter the inputs, and that will be sent to the filter program. Filter program is what it is going to do. Here it is when we call it as a filter program, the filter program means it reads from the standard input and write it to the standard output. From the user terminal, it is reading, it has converted, and it is going to write it to the standard output. Through the p open, we have connected to the parent process, and once again the prompt. This is one simple program to demonstrate to link the filters with the these pipes. Here what we have understood is, what is a filter, what is a normal simple filter, how you can use, how you can drive or how you can use the pipes with the filters. We'll understand the reason why we should do these things. Before understanding that, we will go to this co-process. See, co-process is nothing but any filters, what you see, that you can call it as a co-process when the same program, that program you can call it as a filter and also as a co-process. Then when that program should generate its filter input, it has to generate its filter input and reads the filter output. It should generate the input, that program should generate the input, and also whatever the output it generate, it should read, and that program should read the filters output. Then you can call that program as a co-process and also a filter. You can call that program as an filters. It is not all the shells will support this. So if you write that program and if you run this co-process, it will not run. The con shell only it is going to support, and also it is going to run in the background. See how actually it works is, you can visualize like this. A parent and a child process, One process, you can call it as a co-process. This process, it has to generate the standard input and we have to read it from the standard output. Then this program is called as a co-process. In order to implement this, we need two pipes, pipe 1 and pipe 2. We require two pipes. And one more is, see where actually these things are required. You write something in the standard input and suddenly you will get a response from the standard output. See, you can visualize like this. See, from the standard input, I enter something and there itself, I'll getting the output also. I'll enter something from the keyboard. In the display itself, I'll get some output. It is going to process my input and for each character, it is giving some output. See, until I enter /n, it is not going to wait. New line character. For each character, it is giving some output. In that situation, this will be useful. These things will be useful to show the previous history of the commands what you have entered. In order to store the previous history of the commands that you have entered, this will be useful. Means we are going to transform the input and we are going to show the output. What actually we are doing here is we are going to transformation of the input we are doing and we are going to show the output. See, now you try to understand this when that program is called as a co-process. See here, a parent process, a child process. Here the child process, we are calling it as a co-process. If you create a pipes, then there will be a two ends. There will be a two ends, FD1, file descriptor 1, 0 and FD1 of 1. And if you create one more pipe, that file descriptor 2, it will have 0, one for reading, another for 1. But what we are going to do here is the co-process, the program that the child program what we create, those two file descriptor, we are going to close them. We are not going to use, but the default FD10 will be standard input. By default, FD2 of 1 will be standard output. Instead of using those file descriptors, FD1 of 0 and FD2 of 1, instead of using those file descriptors, instead of that number, that will be copied to the standard input. Means from the standard input, we are going to communicate. From the standard output, we are going to communicate. From this, what you can understand is, see the standard input, it will generate its input. We are not going to give the input. From here, we are going to this, the parent process may going to write the standard input. Then the meaning is it is generating its standard input. From the standard output, the program will read its output. Then you can call this as an co-process. Then you can call it as a co-process. See, a simple program that we will see now, this is called a simple filter. What we are doing is there is one while loop. The while loop means this, what is the condition here is whether the user has entered something, if something is there or not from the keyboard. It is going to read from the standard input. If something is there, then it will come inside. Yes, a scanf. From the scanf, it will read two integers, integer 1 and integer 2. It will read two integer. Then it is going to add and it will be stored in line. See, that will be stored in the buffer called line. In the character array, it is going to store the line. Only this is the program. If you see all the other things, it is just the writing this output writing this output to the standard output file, means to the default, the screen monitor it is going to write. What we are doing inside this, it is just a check whether you have entered or not. After that, get the input, whether it is number of inputs are 2. If the number of inputs are 2, because we are adding only 2 numbers, if the user enters 3 numbers, it will come to the else part and it will show the error that invalid arguments. If the number of elements are 2, get those int1 and get 2, add them and stored in the character array called line. Get the string length, what is the size of the length, whether it is 5000 plus 5000, then it will become 10,000. The number of string length will it is give it as 5. Then that will be returned to the standard output file. Write standard output file number line n means in the line 10,000 plus 10,000, 20,000 is stored in this line. This n will be 5. 20,000 means 5 numbers 200005. This standard output file number means this is a standard file descriptor. Monitor default standard input number will be 0 and standard output for file number it will be 1, I think. That number will be written here. That indicates the output will be shown on the screen. Add 2 numbers, a simple program, add 2 numbers and print it on the screen. This is a simple filter to add 2 numbers. Now we are going to run this program and we are going to store the file as add2.exe, the executable file. We have compiled and we have run once, then that executable file is ready now, .exe. That exe file name is add2.exe. Add2.exe. Now this program, it will be read from the other program. Here there is another program which invokes the add2 co-process. Now this is a co-process. Why you can call it as a co-process? Because it is getting the input from the standard input and it is going to write it to the standard output. When you can totally, it is called as a standard input or means co-process is when we call this from the other program. You see this, then you will understand. Main program, we are creating 2 pipes, pipe 1 and pipe 2. We are creating 2 pipes, pipe 1 and pipe 2, FT1 and FT0. Then we have created one child. Now it is less than 0, then it is a fork error. Or else the parent part is there, another one is child part is there. What child process should do, what the parent process should do. First we'll understand the child process. In the child process, we'll close the unused terminals. From the child end, we don't use this FD1 of 1, FD2 of 0. FD1 of 1 and FD2 of 0. This end we are going to close when we are operating from the child. When we are operating from the parent, we are going to close these two. FD1 of 0 and FD2 of 1, we are going to close this end when we are using the parent. Now we are in the child, we are going to close these two descriptors. Means the other program should not add anything to that. That is the meaning. This is the unused terminal, we are closed. And what 2 adjustments we have done is, we have changed FD1 of 0, we have changed FD1 of 0 to standard input. That we have changed, right? That is what we are doing now. FD1 of 0, we are changing it to standard input file number. Now the new FD1 of 0 will be standard input file. The FD2 of 1, we are changing it to standard output. Duplicate 2 means it is going to change from, this will be the old file descriptor, this will be the new file descriptor. Duplicate 2 is nothing but it will change the old file descriptor to the new file descriptor. These numbers will be the this numbers, what the numbers will store inside this 2 will be this number. What is the number? There will be an integer for this number, standard input file number, I think 0 and 1. It will be 0 and 1. Those numbers will get stored here inside this. Then you cannot call it this as an FD1 of 0. That is a standard input and standard output. After doing this, what these two if conditions are doing is just FD1 of 0 we have changed it to standard input, FD2 of 1 we have changed it to standard output. These numbers are stored inside these file descriptors. After that, we are going to execute L. We are going to execute the previous program, addition of two numbers. Addition of two numbers we are executing. The control from here, it will go to that program, and there it will read the two numbers and write it to the standard output. After that, what we are doing here, we are coming to the parent now. We are closing the other end. We are closing the other ends. And inside this fgetS. What is fgetS will do? It will get something into the file from the standard input. It will store it in the line. What is there in the standard input? Now, in the standard input, the two numbers are there. If it is not equal to null, means something is there in the standard input, then it should come inside. If nothing is there, means it will go out. If it is not equal to null, means something is there. This line we are going to store it in n. Now what we are going to do is write fd1 of 1 into the line. This fd1 of 1 is, say this, fd1 of 1 is, from here we are going to write it to the line. From the standard input we have got something, write into the line, write error to the pipe, means if it is not possible, means it cannot write it into the pipe. What we have done is, something is there in in the standard input, we have read and we have passed this, through the pipe, and it has reached the child process. Now it is in this process. We have passed the something into the program. Now what the next thing we are going to do? N equals read fd2 of 0 line comma max line, means from the fd2 we are going to read fd2 of 0, which is called fd2 of 0. From here we are going to read it from the standard output. The parent process is going to read it from the standard output. If nothing is there, then close, means n equals 0, means if nothing is there, then the child has closed the pipe. See, totally what this program is doing is, whenever you enter something, in the meanwhile, in the background, something will be captured and processing will be done. Some transformation will be done on the input, and that will be shown as an output. Why this you are going to call it as a co-process is, why you are going to call? Because from that program itself is generating its standard input, and we are going to read that standard output. The program itself is reading the standard output. Then we are going to call it as a standard output. If you go through the program once again, then you are going to understand this. Even though if you kill the add to process, that program will not terminate. The signal handler will handle the things. The next thing we are going to discuss is FIFOs. What is this FIFO is? First in, first out. First in, first out, they are called as the named pipes. The first in, first out, we are going to call it as a named pipes. When we can call this as a first in, first uh, named pipes is usually always the communication, it will not happen between the related process. Always the communication will not happen between the related process. That is why we are going to, you are not going to use the pipes. Instead of that, we are going to use the named pipes. Instead of that, we are going to use the named pipes. These named pipes, what they actually do in the background is they are going to create a file. It is just very similar to creating a file in the background. This entire details, how to create the file, what is the syntax of the FIFO, everything we can discuss in the next class. We'll discuss the detail about this FIFO in the next class. If you have sent the attendance, you can exit.